Hi everyone! In this Algebra 2 video, we are going to be going over an introduction to polynomials. Specifically, we won't be doing a lot of operations or anything, but we are going to learn to define and classify polynomials. So this video will largely be referring to vocabulary. Okay, so here's the definition of a polynomial. So a polynomial is an algebraic expression that is a sum of terms. Okay, so it's just a bunch of terms being combined together. Now, the specific requirement in order to be a polynomial is that each term only contains variables that have whole number exponents and real number coefficients. So the real number coefficients part is really just referring to this type of information right here. It's basically saying that you don't have any imaginary numbers involved in the function. Okay. The whole number exponent part is really important to point out because you might remember from the first semester talking about what a whole number is. And a whole number is basically our counting numbers starting with 0. So while you might think that a negative integer is a whole number, technically it is not a whole number, right? Negative integers are just negative integers, okay? Whole numbers start with 0 and then they are positive numbers. So what that means is that if there is a negative exponent, not a polynomial. Fractional exponent, decimal exponent, radical exponent, there's a variable in the exponent, right? All of those things would cause this to be not a polynomial. And then you can copy down those examples there. And we will move on. And now we're going to look at some examples of things that aren't polynomials, right? So we have another example here that is a polynomial, but you can look at the examples that are not polynomials, and I would just like to point out why they are not polynomials. So here we have 3xy to the negative 2. So we talked about how you need whole number exponents, and negative exponents are not whole numbers. So since there is a negative exponent in this expression, that would not count as a polynomial. Okay. Now, this example here also does not count as a polynomial. So the reason is because x is in the denominator of a fraction, and we didn't really talk about that on the last slide, but your variable cannot be in the denominator of a fraction in order to have a polynomial. The reason this doesn't count as a polynomial is because essentially what that function represents is 2 times x plus 2 to the negative 1. Right? So if something's in the denominator of a fraction, we know we can flip it to the numerator by making its exponent negative. We talked about that in first semester with exponent laws. So essentially this is a negative exponent, even though you don't see it written on the page. With that being said, I'm not expecting you to rewrite it like this. Okay, that's just the explanation behind why. And you really need to know that if the variable is in the denominator of a fraction, then it is also not a polynomial. So now we're going to go through a few examples to classify as whether they are or are not polynomials. So this first example here, x to the third minus 2x to the fourth plus 7. So I'm looking at these terms. I have x to the third, that's a whole exponent, right? 3 is a whole number. Negative 2x to the fourth, 4 is also a whole number, so that's fine. And then I have a constant added at the end, so that's fine, positive 7, okay? All of this checks out. Every exponent is a whole number, so I'm good to go, and my answer here is yes, this is in fact a polynomial. Looking at this example here, I'm working through, I'm like 2x to the 7th, that checks out. Negative 2x to the negative 2. Oh, so there's my red flag, right? I have this negative exponent, okay? So as soon as there is even one negative exponent, your answer is no, this is not a polynomial. Looking here, okay, this one might trick some people. We looked at this in class, okay, but look here, 2 to the 3x. So my exponent here is 3x, okay? Some people's tendency is to think, oh yeah, that's a whole number because 3 is a whole number, okay? But x is not a number, it's a variable. It represents a number, but that numbers can change, right? That's the whole idea of a variable, it varies. Okay, so because x could be a variety of different options, the variable is in the exponent. That means that this is not a polynomial. Okay? If a variable is in the exponent, what that is an exponential. And then one last example here, f of x equals 9 plus x over 5. This is another one that sometimes would trip people up because you might see here, oh, you have a fraction, and some people are like, oh, fraction bad, not polynomial. But in this case, you'll see the fraction is just a number. So I'm taking x, whole number exponent, right? My exponent is essentially just 1, right? It's not written in there, but it's just an x. So having x there is fine. And I divide by 5. That is the same as saying 1/5 times x, right? So dividing x by a number is the same as just having a coefficient. And obviously you've seen all these examples had coefficients, so that is totally allowed. Okay, so the only issue with the fraction is if the variable is in the denominator, or in other words, the bottom of the fraction. Since it's not here, this is, in fact, a polynomial. Okay. Now we're going to talk about what standard form is. So in standard form, the exponents descend as terms are listed. So what does descend mean? Descend means that they get smaller. So you start with your largest exponent first, and then they go in descending order, meaning smaller and smaller every time. So examples in standard form include 5x squared plus 7x minus 10. That's because my first exponent is 2. My second exponent, plus 7x, that is essentially an exponent of 1, right? We don't write that, but we know that it's just x to the 1 if nothing else is written. And then the constant comes at the end, right? The constant essentially means an exponent of 0. It's sort of like if you had negative 10x to the 0, right? That's sort of how it falls in line in this descending order, because x to the 0 is just 1. So that sort of like represents the exponent in the constant. But if you just remember that the constant always goes last, then you'll be doing just great. Right. Other examples are also listed there, but you'll notice every time you go from the largest to the smallest exponent with the constants at the end. On the right side, you can see some examples not in standard form. So for instance, 6x minus 12x squared, you notice that my exponent actually gets bigger throughout. So I go from x and then x squared. Same thing in the second example. Like I start with this constant right away. I know that's not standard form. And then I have the biggest exponent, but then I have a smaller one, and then I have a bigger one again. So it's just sort of in a jumbled up order. So anytime we aren't perfectly in descending order, like we were on those examples in the left, if there's even one term that is out of order, then you are not working in standard form. Okay. So just going through a couple examples, are these in standard form? So this first example, we have x to the third, and then x to the fourth comes after. So this right here, that's the largest exponent. It's not coming first. So no, this polynomial is not in standard form. It does not have exponents in descending order. Here's an, oh, I literally read the instructions wrong. We're going to come back to this one. So no, it's not in descending order, but it actually asks us to write this in standard form. So that's a good skill to have. We'll go over that. So in standard form, the term with the largest exponent has to go first, right? So I see that here, negative 2x to the fourth. Again, remember we're looking at exponents. So we're looking at those little numbers up top, not coefficients. Some people get confused there and think the largest coefficient has to go first. But this is all based on exponents. So I'm going to take that entire term right here, negative 2x to the fourth, and I'm going to put that first. Please make sure that when you have a sign, you attach it with its term. Okay, don't accidentally drop the negative. So I start with negative 2x to the fourth. My next part is going to be a positive x to the third. That is because that is my next largest exponent. And then again, always end with my constant. So there we have it in standard form. Looking at another example, once again, we don't care about the coefficients in terms of writing this in standard form. We are looking at exponents. So I'm starting by looking at this whole thing and finding my largest exponent, and that occurs right here. So that will be the first term that I write. So f of x equals x to the fourth. And then where's my second largest exponent? Well, constant. That's an exponent of 1. Oh, here's an exponent of 2. So that's going to go next. Okay. Then I have an exponent of 1 here. So that goes next. And then my constant goes last. So here we have it in standard form. One thing you'll notice is I did not combine any of these terms. Sometimes people feel like they can. Remember, if you have two like terms, then you would combine them. For instance, if I had 6 plus 3, like I would say that's 9. If I had 2x plus 3x, I would say that's 5x. Okay? But all of these terms are not alike because they have different exponents. So if they don't have the same exponent, then you cannot combine them. Now looking at important parts of a polynomial. So first we have a leading coefficient. What is that? That is the coefficient, right? So the number being multiplied out in front, right? That's a coefficient. The coefficient of the term with the largest exponent. Okay. So here in this example, my leading coefficient is 2 because if I look at all these terms, I see this is written in standard form. So 2x to the third, that is the term with the largest exponent. Its coefficient is 2. Now, common misconception. Some people think that leading coefficient always means the first coefficient. That is true if we are working in standard form, right? For instance, we are in this example, and that's where it gets the name leading coefficient. That is so illegible, but that says standard form. Okay. Yes, the leading coefficient comes because it should be the leading coefficient if we are written in standard form. Usually, we'll work with polynomials and we will write them in standard form. But if it's not in standard form, you do have to look throughout this and find the term with the largest exponent because that term is what is going to determine your leading coefficient. The term with the largest exponent, this is just going to have the greatest impact. That really determines the overall behavior of the function, what the function looks like in the graph. Obviously, everything has a bit of an impact, but the term with the largest exponent really has the largest impact and determines like end behavior and stuff. So that is sort of the key term out of the entire polynomial. Okay. Next, we're talking about the degree of a polynomial. The degree is just the largest exponent. Okay. So in this case, right, I mentioned this example is in standard form. So the largest exponent is in this leading term, this first term. So my degree is 3. Okay. And again, we use the degrees to refer to exponents. So if you said something's like the third degree, that means an exponent of 3. Or if you said something is a fifth degree, that would mean the exponent is 5. So the degree is just the largest exponent in the expression or equation. Okay. And then your constant is just your plain old real number at the end. It might not always be written at the end, but in standard form, it's at the end. It's just a real number. I call it sometimes a plain number. There's nothing surrounding it, just a number. In this case, my constant is positive 7. Okay. Now I'm going to determine these key features. So first, that's leading coefficient. Now, I could look at my very first term and say first term is x to the third. Maybe my leading coefficient is 1. But hopefully you listened to me on the last slide and you're like, oh no, I need the term with the largest exponent, and that is right there. So my leading coefficient is actually the coefficient of that term, -2. My degree, again, is the largest exponent, so that is going to come from the same term, always the same term you get the leading coefficient from, and that exponent is 4. And then again, in this example, same as the last example, my constant is 7 because that is the plain old number being added on at the end. One more example here. We see my leading coefficient, negative 3x squared minus x to the 7th. Again, you might think it's negative 3, but be careful, right? My leading term, whether it's first or not, is always the term with the highest exponent. So because negative x to the 7th has the higher exponent, that makes it my leading term. That is where I pull my leading coefficient from. Now, you don't actually see a number out in front. You do see a negative sign. The number is not written in there, but again, if the number isn't written in, that's always just, it's an imaginary one. Right? I'm subtracting x to the 7th. I only have 1x to the 7th. It's just sitting there. There's just one of them. So I don't bother writing that in. The coefficient is negative 1, not just a negative sign. And then again, degree is that exponent from the leading term, 7. Now, you don't actually see a number added or subtracted here by itself. There's no like plain numbers. That indicates to me that my constant is 0. Okay, you wouldn't say that like it's not applicable or none, okay, because even though you wouldn't write it, it's sort of like how the coefficient, it's not like there's no coefficient. The coefficient is 1. Well, there is a constant. It's just 0, so you didn't bother writing it. Okay. Moving on to classifying polynomials. So we classify polynomials in 2 ways. One is by the number of terms. The other is by the degree, or in other words, the largest exponent. So number of terms, we have classified this before. You've probably seen some of these words such as binomial. We talk about factoring a trinomial as the product of 2 binomials. So that's where those words may have come in before. I know I certainly was using them in the fall semester. The examples at the bottom here, there's just more examples, but your key information is found here. Okay, we have a monomial. Mono means 1, right? So a monomial has 1 term. Okay, negative 2x to the 5th. What do I mean by term? Just to clarify, terms are the parts that are separated by addition or subtraction symbols. So for instance, looking at this 4-term polynomial, right, we have a term here, and then as soon as I have an addition sign, starts a new term. Then I have a subtraction sign, that indicates a new term. An addition sign, that indicates a new term, right? So terms are just these pieces that are separated by the addition or subtraction signs. Right? So my monomial only has 1 term. My example is negative 2x to the 5th. Okay? A binomial has 2 terms. Bi meaning 2. Right? I'm just trying to underline this. Right? So 2 terms, x squared plus 5. Next is my trinomial. Tri means 3. So a trinomial has 3 terms. 1, 2, 3. Yeah. And then I have a 4-term polynomial. You could have a 5-term, 6-term. You could have a 27-term polynomial. Okay, but we don't have specific names for those. You would just mention however many terms it is and call it like that. So this is a 4-term polynomial because it has 4 terms. Okay. So we are going to classify the following in terms of how many terms there are. Didn't do that on purpose. Okay. But we're going to classify in terms of the number of terms. So here we have g of x is equal to 4 minus 2x. You'll notice 1, 2 terms. 2 is the abbreviation bi, right? Bi means 2. So we here have a binomial for 2 terms. Here we have another example. Try to think about this. How many terms? What's it called? I'm going to count the terms here. 1, 2, 3. So 3 terms is a trinomial because tri means 3. Okay. Last thing we're learning in this video, I know it's getting kind of long, but we're talking about types of polynomial based on degree. So again, the degree is the largest exponent. And so you've heard some of these words before, I'm sure. Constant, linear, quadratic, cubic should be familiar. Then we have quartic and quintic. So again, these are the names based on the largest exponent. So if my largest exponent is 0, meaning there's no variable there written, right? That is called a constant function, right? And you see that makes sense with f of x equals 5. The only thing going on in that equation is the constant. Okay. Next, we have linear functions. That is the degree of 1. So essentially, you won't see an exponent written. You'll see a variable without an exponent written, which means the exponent is 1. My example is 3x plus 2. Right? Linear functions are lines. You learned about these in Algebra 1 a lot. Okay. So there's no exponent written on the x, or if it is written, it would be a 1. If you have a degree of 2, meaning the largest exponent is 2, that is a quadratic. We just did our unit on quadratics, so that should be familiar. X squared minus 4. Next, I have a cubic, right? We've talked about cubes in terms of like, if you're cubing something, it's taking it to the third power, right? We talked about like cube roots. So the degree of 3 is cubic. That means I have an x cubed, or an x to the third, and that's the largest exponent. Okay. Then I have quartic, okay? Quartic means 4th degree, right? Sort of like quarter, like you see that where that 4 comes in. So 4th degree, my largest exponent is 4. Negative 3x to the 4th plus x is an example. Okay. And then after that, the last one we have listed here is a quintic, okay? That means 5th degree polynomial. So there's this whole long function over here, but you see that this first term has x to the 5, and that is the highest exponent in this function. Okay. It is possible to have functions with exponents higher than 5, but once you get to a number past that, there's no specific name. You would just call it like a 6th degree polynomial, or a 7th degree polynomial, or 107th degree polynomial, right? You just name it by the number instead of using a specific name. So we are going to classify this. We can now classify it both by degree and number of terms. So I'm going to start with the degree. So I'm looking for what is the highest exponent. And I'm looking, and the highest exponent is 3. That indicates to me that this is a cubic function. Okay. But I can also classify by the number of terms. So I have 3 terms, 1, 2, 3. So this is actually a cubic trinomial. Right? And that is how you would list it. We list the classification based on degree and then number of terms, because the degree is more important. Okay. This one here, I'm again looking to start by classifying by degree. Okay, what type of function is this? Well, I have a constant, but then I also have this negative 2x. So essentially this exponent is just 1 because there's nothing written there. This is the equation of a line, so this is a linear function. Okay, and I underlined both my terms. I have 2 terms there. So because it's 2 terms, this is what we would call a linear binomial. Okay, and yep, that's it. Oops. So that is it for this video. If you have any questions, definitely let me know. Hopefully this helps you finish your homework on Delta Math and you understand this. But again, if you don't understand it, you are always free to ask me a question. So shoot me an email, come in at office hours, whatever you need to make sure you're solid on this.